Okay, so yeah, thanks everybody for coming after 3 or 4 really long days of conferencing, and at the last session we really appreciate everybody showing up. So I'm Tracy Miranda and this is Jonah Graham, and today we'll be talking to you about a common debug protocol. So as developers, I think we're all aware that in this day and age you've got languages and frameworks just changing at a breakneck pace. And the tools are really struggling to keep up. And on top of that, you've got this big move to putting things into the cloud. And the cloud environments aren't quite where desktop is today. So all in all, as communities, we're evolving around solutions that work for multiple languages in multiple environments. So for language support, that's pretty much being solved today by the language server protocol, which gives, I think we've had quite a few talks at this conference already, but it gives a way for different IDEs, different editors, whether they're cloud-based or traditional desktop, to reuse servers for, well, as people call them, language smartness providers, and have a whole host of functionality written once that can run everywhere. So some of the benefits that we're already seeing from the language server protocol. First of all, yeah, just the momentum of it is just going really well. Back in June, when we were talking about it at Eclipse Con France, there were about 27 language servers implemented for different language support, and now we're up to 46. So in terms of how fast everyone's rallying around this, it's really impressive to see, as not just the Eclipse community, but communities of developers in other arenas. So language server protocol, it basically means developer communities and tools are restructuring to work together and be more effective. And it will give desktop editors the chance to keep up much better with changes in languages. If you think about something like Java, which is switching to a release schedule, just going to be released much more frequently. We're going to have much more regular language updates coming out. And then for cloud IDEs and cloud editors, they look set to significantly improve their functionality as well. So now that languages has sort of been solved, the question that comes up is, what about debugging? And I often have this question of whether with new languages, whether people are really debugging in the traditional sense. So I'm really glad to see lots of people sort of show up. And I'm assuming, yeah, everybody is debugging and using sort of the complex debug tools, so not just putting a printout in code. We've moved a long way from bugs being actual bugs from the days of Grace Hopper, who coined that term. From then on, when anything went wrong with the computer, we said it had bugs in it. So we know a lot about debugging in this community. Eclipse has the original sort of fully featured debug framework, and when you sort of break it down to what's involved with providing a good solid debugger, there's basically just quite a different number of things that have to be considered. So from the minute you launch, that you're dealing with the processors, and sometimes we have support for multiple launch configurations where you might be debugging a client and server together, or multiple languages across something like JNI. Then you've got the debug model itself, and this deals with the target, the processors, and the threads. So you might have multi-threaded, you might have multiple processors, as we do in a lot of the embedded space. Run controls, your standard start, stop, steps. Breakpoints themselves is kind of a huge area for everything from line and address to complex things like deferred breakpoints. Then you've got source lookup, variables, console. Each of these areas, I think the point I want to make is each of them has some significant functionality. So if you are talking about implementing a debugger, it's just not a task to be taken very lightly. And then the debug framework also has specialist views. There's a whole UI front end as well. Things like memory views and expressions. Then on top of that, we have other frameworks at Eclipse, and I can see quite a few folks here from the CDT community probably be quite familiar with the CDT Debugger Services framework. Now this, although we use it just in CDT, in its own right is a fully fledged debug framework, which there had been talk of pushing it up to platform debug, but it just never happened for whatever practical reasons. And DSF, it provides a fully asynchronous environment. So you could run it with hardware that's slow or remote, and you never lose responsiveness, and you can extend it in many, many different ways. But one of the things about it was, while it was very powerful, it was extremely complex. I think we've struggled to get people to make contributions to that code, and just debugging the debug code is problematic, which is never what you want things to be. But having said that, DSF added some additional support, things like disassembly views, step backwards, which if your debug backend provides that, is really nice to have, register views, and a really nice feature in the embedded world is where you can drive the debugging just by using GDB, so you can do it from the command line, so you can just do a bmain to set a breakpoint, and your IDE stays up to date. And then in its own right, DSF, take for example a GDB implementation, just has a whole host of different, I guess they are actually implemented as different services, so you could say microservices implemented for that. Okay, so Eclipse has these fully featured frameworks, very industrial strength, very flexible, but very complicated to develop, and of course suffers from the same problem of you can only implement things in Java. So then we're sort of saying, well, can we look for something that's similar to the language server protocol? Yes, Microsoft already provide an equivalent to that, which is the debug protocol. So it's created much earlier than the language server, but I would say it's less mature than LSP. So it's got kind of, it hits the headlines in terms of the main functionality, but there's lots missing compared to Eclipse. And one difference with the language server protocol is it communicates to students stood out. Shall I give you, go ahead and you can do this bit.
You're going to stay next to me. Try not to walk around the room too much. All right, so if you've seen how the language server works within VSCode or anywhere else, the structure will seem pretty familiar to you with a debug server. So we have VSCode, or the client or the IDE, sitting over here on the left. And using the debug protocol, it talks to things which are called either debug extensions, and those debug extensions actually have the adapter that does the work. So we end up with is lots of different processes of the IDE, the debug extension host, and then the actual adapter itself communicates with the IDE over stood in, stood out typically, although there are other options of how to handle that. And then at the other end, that's the traditional debugger. So whether it's like Node with V8 or any other actual debug implementation that already exists, this debug adapter is converting the debug server protocol into whatever protocol that backend already uses, so that it provides that common interface. So if we just go to the next slide. So I'm from the CDT side. The thing I'm really interested in, let's get an implementation of using just GDB as normal and having a debug adapter that's for GDB that connects in with that. Okay. You want me to do this one? Okay.
Sure.
All right. So similar to the language server protocol, these are the benefits we have with the debug server protocol. We do have this separation of the client and the server. We end up with a server which is headless, no GUI, none of that interactions. So we end up with testable debug server. Anyone who's tried to write tests for their debugger in Eclipse probably knows that can be quite complicated. Being abstract as much of that out to the real back end as possible helps. One of the other really nice benefits of the debug of this separation is running in separate processes. It means that you can write the debug adapter in a language most suited for the other end of that chain. So if you want to get your C and C++ developers involved, and you want to have them, contributing to this debug adapter and adding that cool functionality, maybe Java isn't the easiest language for them to get up to speed on, but if it's in C or C++ already, they can come contribute. Same thing, Ruby, Python, all of that. Let's put the debug adapter in the language that makes the most sense for the language you're debugging. And of course, reusing across the IDEs. We're going to show you a little bit of that today. Right now, the debug adapters are pretty much just for VSCode. There's no one else that really has them yet. And then finally, we can keep a faster pace with all the underlying tools. GDB releases 2 releases a year. They don't seem to pay any attention at all to the simultaneous release for their release schedule. So it'd be nice to be able to keep up with that. Back to you.
Okay, so in terms of available debug implementations, there's already quite a few extensions out there for the languages you can see. And similar to the language server, I expect this is something that will grow and grow. Just one thing worth noting, not all of these are open source. So some of them, the source isn't necessarily available. Some of the source is available, but Microsoft has some interesting license conditions about that you can only it limits where you can use them to Visual Studio and VS Code. But things like, there's a native one for C, GDB. There's a Python one that's completely open source and available. So it's just a word of warning, if you are interested in a specific language, just check out the licensing specifics. Okay, so for a demo, so we're going to show you what we've been working on and how we've gone on integrating things into the different IDEs. So we're going to be using this mock debug adapter that if you go to try and write a debug extension in VS Code, they recommend you use this as a template for getting started. So it simulates a debugger. What it does is the source code is a readme.md file, and you can step over each line. And one of the reasons it's good to use this is because it provides full trace information, so it made it really easy. So I'll show you what we've got, and we're going to look at 3 different IDEs, so VS Code, Eclipse IDE, and Eclipse Che. And we're going to look at 7 bits of functionality, so launching, source lookup, inserting breakpoints, variables, run control, with stepping over call stacks, and just terminate. So we're going to see if we can have that same functionality in each of the IDs. So let's start with VS Code. Is this running? Okay.
Legible enough back?
Dark themes are great until you put them on a projector. Okay, so we've got, so this is VS Code, for those of you not familiar with it. And we've just got a dummy README file over there. So in VS Code, let's see if I even remember. Can I just start debugging? I'll click debugging. We get a little floating toolbar up there. And the first thing it will do is connect up the source. It connects up the source variables. In this case, the example just has some fixed variables. So it has 2 scopes, local and global. And those are just fixed variables. Nothing changes about them. But you'll see as I click about, you've got the debug trace on. So there's messages being sent down to the client and responses being received, from the client to the server and vice versa. Okay, we've got a couple of breakpoints set, but first let's just take a couple of steps. So each word on the line is interpreted as a frame, so you can see the frames over here, so that gives you your call stack. So we can take a couple of steps and you'll see things update. One of the things VSCode does that's quite nice, it's got step back implemented by default as well. So we step over there, then we've got a breakpoint. We can do a continue and we'll stop at the breakpoint. This example has a few advanced features on breakpoints. Like if you put a minus, the breakpoint gets installed on the line above. If you have a plus, breakpoint gets installed on the line after, just to show how in real code you might have the breakpoint move based on where the actual executable code is. And if I continue again, if a line has the word exception in it, then we treat that as an exception breakpoint. So you can see here on the call stack, it talks about being paused on exception. So yeah, so you can see that that's kind of the basic functionality, but in several different areas. Anything I'm missing? Worth mentioning? Oh yeah, you have it open. Okay. Then in terms of launching, VS Code doesn't do kind of wizards or GUIs. It's not part of the philosophy. So you launch it off the back of this launch.json file. So that will specify that in this case we're using this mock debug, and this is the program file we're debugging. And I think it gives you completions in general. So I think if you did. Yeah, so it's got some completion, so it can show you all the settings that would be available for that launch config. Okay, so that's how they handle launch. Okay, so that's VS Code. So I'm going to hand over to Jonah to show Eclipse.
All right, so same thing again, but in another IDE. So so hopefully you got an idea of we're debugging readme.md files. A bit strange, but it makes it really easy to not pay attention to the actual hard part of the other side of the debug adapter. We're worried at the moment just about IDE talking to the debug adapter. And so we're going to do the same thing now in Eclipse. So just like you saw in VS Code, we have a little bit of JSON in here that gives off all the information, the path to our README file. We don't have an extension mechanism that understands debug things yet, so the actual wiring up of, say, to launch node with what the debug adapter implementation in JavaScript is, we need to provide that manually for the moment. But just like for the language server protocol implementation in LSP for E, we expect a similar solution to go in for DSP for E, which understands how to do the launching part, so the users aren't having to know the name of the path to their random JavaScript file. So
I guess I was just saying it's probably worth mentioning this is just for kind of the proof of concept way of doing it and just making it easy to see what's being launched, but this isn't something an end user would ever see.
all right, so I'm just going to start debugging. We have so now we're into the prototype code. The other stuff was actually Microsoft's release code. So here we're stopped. We're in a this is a README, so the lines this is a README. As you can see here we have our individual frames within our thread. We have our program being debugged. We populate the variables view on the frames. So we've got two scopes, so we've treated as the roots within the variables view. And we've got some variables. You can probably all see it now because it's not a dark theme. We have an object, so you can keep on expanding forever, and this will keep going back to the adapter and keep expanding and getting the variable references to display that. We can step through the code here, so we just step through the lines. We're for testing debugging. And we can put breakpoints in or not. So let's get rid of them to start with. So put a breakpoint in, the next line's not as convincing. I'll run to that exception there. Put a breakpoint down here. We have a breakpoint on line 7, which is down there. Press continue. Stop on line 7. Everything's working. What we're doing for how we handle those breakpoints, one of the things that makes Eclipse substantially different than VSCode and other IDEs. I'm going to stand up again. Than other IDEs, like Che, is that there is a single breakpoint type in VSCode. You open any file, whether it makes sense or not to have a breakpoint on it, like an MD, and you can just put a breakpoint on any single line, and it's fine. How Eclipse is implemented is every single editor and debug target combination needs to provide their own breakpoint types. So we have a little of a mismatch that we get to resolve here and saying, well, we just want line breakpoints on everything. You know, we don't know what that debug adapter is really going to be able to support. We don't want to have to write that custom stuff. So what we've done is we've inserted for this prototype on the generic editor and the plain text editor. You can now insert breakpoints in any line if you want, and theoretically we could do that across the board. But of course, that's likely to interfere with other people. So there are some technical decisions we need to figure out how to present it in Eclipse still to users. However, in the short term of saying, well, actually, I'm going to support a new language with a debug server, and you're going to support it with also the language server, that is an easy solution, and we're actually quite good to go there. All right.
You can go ahead and do Che.
Okay. Che. Right. So.
Is people familiar with Eclipse Che generally? Yeah, seeing some nods.
Okay. So in Che, we do basically the same thing. So we created a new debug configuration for the remote debug protocol. And it has a command, and it has a bug, and it has the JSON parameters down here. The bug is mine, but I just haven't fixed it yet. So when we can launch debug, let's launch the debug adapter, and we're stopped on the line README. And over here we can see we have the threads, one thread in this case, and the frames. And it's slightly too small to see the variables, so let's just make the variables visible. And we got our variables coming through there. So we got our locals and our globals. These are our breakpoints. So we just insert a breakpoint and continue to it. We stop at the breakpoint. We can then explore our state and step over the lines as we go. And that all just works. So.
Yeah, maybe we can show quickly, we won't go too much into what the code looks like, but I'll just give you a quick overview of the protocol, or do you want to just show the generated? So back in Eclipse.
Yeah, sorry, I left a lot of other Eclipses running. LCDSL.
That one?
No, not that one. That one.
That one. Okay, so yes, I'll show you the couple of interfaces. These are generated from the JSON file.
A combination at the moment. The iteration is generate some Java, tweak it a bit, update the generator until I've got the interface, the Java implementation I like. There is a JSON file that describes the debug protocol, so we use that as a source to generate the Java, and that makes it quite nice. But then there's some special cases that we have to resolve, but we're working on that.
Yeah. So just to give you kind of just a quick overview, you've got the client with the stopped, continued, terminated side, and then you've got, this is what the server will look like. So you've got the interfaces there with the steps, the run control methods, the starting, terminating, setting breakpoints, and then the debug protocol itself is just a whole host of different types of responses. So let's pick a request. Do I say breakpoint?
The requests are all start there. So run in terminal, launch request.
yeah. So, for example, you'd have a launch request where you'd have the command, and you'd pass in the arguments, and then similarly, the protocol will define the response. So this would be the launch response. So it's just a case of mapping that to the different concepts in the IDEs. So it's worth saying with Eclipse, the existing debug framework was pretty complete, and the extensions work really well. So we didn't really have to change anything. So we could take advantage of all the existing platform debug extensions just to integrate this, to hook up kind of calling against this protocol with the existing mechanism. So that's really nice. Okay, where's the slides? Oops. Having trouble seeing. Okay, so that's demos. Next steps. So I didn't update these steps, but yeah, so we're talking about what's happening next. I think we've had some chats here at EclipseCon, and we've now looking at making, contributing this not as a new project, but part of, we'll do LSP4E. So I think the scope of LSP4E originally was scoped to include the debug clients, so we'll look at contributing that into Eclipse IDE so people can start running their own adapters against that. We're also going to look at doing a pull request, and we've spoken to the Che folks about getting that into Che. So the protocol itself, there's lots of features that aren't included, some of the things like memory and registers, so there's a lot to enhance on the pure functionality side. And I'd say there's still lots of idiosyncrasy, I can't say that. Lots of strange things that I think need to be kind of tightened up on the protocol, just some agreement on kind of some of the keys in the JSON file. So that's some area we can look at. But yeah, just to wrap up, the debug protocol, it provides all the same advantages as the language server protocol. While it's less evolved, it still has enough there that it shows huge potential. As long as we can kind of, bolster it for all the missing functionality. So, it's not going to be something that will instantly give us industry standard debugger replacement, but over the time, and we've seen if we kind of get everybody working together, we can get there quite quickly. And going forward, it gives us an effective way to maintain debuggers in Eclipse and future cloud IDEs, and also just kind of keep up with whatever DSL you guys want to create. And yeah, great. So thank you very much. Do the voting thing. But yeah, now we'll take your questions.
Is it on GitHub, the source code, or where is it?
Yes, good point.
It's on GitHub, but it's going to be a pull request and a Garrett in the next couple weeks. You can go have a look at what my prototype code looks like, or you can wait a couple weeks and see code that might be worth reading. So,
what are you? Do you want to get your code is?
In our respective accounts.
Yeah, so I can send you a link, but we hope to put the pull request in quite soon. So.
Yes.
You said that most of debugger extensions will just work with that. Is that something like, for instance, show logical structure? Is that working with it, or do you need a special adaptation there?
That one. We need a special adaptation. So the debug protocol is just not as fully featured as Eclipse. Yeah. Eclipse has however many years of adding incredibly great features to it. So no, we're not going to have you don't get those things out of this. But on the flip side, one of the interesting things they do have implemented in the protocol is step backwards. So hopefully we can get step backwards, into the platform, or either that or we'll have to contribute it in here as extra stuff. So.
Is it drop to frame in the protocol? So.
Do you know?
Yeah, it might be actually. It might be. Can't remember.
And does it have a way of evaluating expressions?
Yes.
Yeah,
And
expressions.
it has expressions and hovers. It has some step into functionality. So some of the stuff is done very generically. So you can ask the debug adapter, well, what targets do you have that I can step into? And then if that debug adapter understands how to do a step into something, then it can tell you. And so I think adding all these extra things. But for us, one of the big places that we see that is missing. It doesn't really. No one's done a really full C type implementation. Certainly not an embedded C implementation. So adding all the advanced registers, advanced breakpoint support, things like that are still in the. Yes.
First thing is the debug protocol asynchronous, so you get like you don't need to wait for the response. You need to block wait.
It's an asynchronous protocol. So you say there's a request and a response message, and there's an asynchronous event message,
right.
And they can theoretically go both ways. But at the moment, the debug protocol, it's the client, the IDE makes requests, the debug adapter gives responses, and when the debug adapter has anything it wants to announce, it sends events.
Right.
So.
And second question is it extensible?
That's where we're working. So it is definitely extensible, but the extensibility isn't formalized.
Right.
So the language server protocol already has that formalized within it. The debug server protocol doesn't in the same way. So we'd like to do that, and we're going to lead we're going to follow where others have led, or we're going to lead where others have followed. I don't know. But we'll be looking to do the same thing. The protocol is quite similar in structure to the language server protocol. However, because it predates it, and it predates JSONRPC 2.0, it's not exactly the same. So the question is, do we actually go fix that? Yes?
You mentioned you want to do a PR for LSP4E. Should we also put the protocol definition palettes to LSP4J?
Yeah, we have to, it has to go into one of those two places, so it makes sense to have an LSP4J. The protocol definition. We have that split in two plugins now. We would call
I
it.
saw you make use of that. The debug protocol is not strictly JSONRPC.
It's not strictly JSONRPC. So what I've done for the, so we are using LSP4J JSONRPC's implementation, and we've supplemented it to make it match. They are almost identical. It uses sequence, I think, instead of ID, right? As the key for the numbering system, and it's a bit more chatty in terms of having extra fields that actually no one's using. But so right now I put some extra adapters in. So for the serializer and deserializer, it uses my one, but the rest of the JSONRPC, it just uses a standard JSONRPC implementation.
It would be nice if you make a PR for
Yeah,
it.
so yeah, we should have said that. That is the other place we are planning to make a PR for it. So, yes.
Are there any plans for Microsoft to get the two protocols more aligned with each other?
I don't know.
And then the second.
Okay.
You can relate.
I can tell everyone now.
Yeah, I just recently talked to the product manager of VSCode, and they say it would be nice if the debug protocol was really JSONRPC and would be the same, and it also would be nice if they would move it to a separate repository, just as the language server protocol, make it kind of more like all the same. But it would break all the 29 debuggers. I think there are even more than 29. They said that like every debugger that is supported is using that protocol. They don't have an API. And so they currently, from their perspective, don't see a lot of value in other than just cleaning it up. It would break a lot of extensions. That's why they don't plan to do that.
So my perspective on that is that the protocols are so close that the implementations don't have to change. Only the protocol does. So that's they are that close. So and if that can be validated.
Change. I mean, I think
No, it would be a breaking change, but we could VSCode could support both versions of the protocol for very little overhead and capture that within a small slice of the stack. It doesn't spread out across all the stages of the stack, and then they could deprecate the old one if they wanted to or not.
Yeah.
So, but right.
With respect to just making the debug server protocol a bit more popular or supported, like the language server protocol, they just said it's a matter of resources at the moment. They want to do the stuff they do in a great way, and opening another project is kind of challenging.
That's useful.
I think if there is value for us as people involved, debuggers in the community on multiple tools, turn the protocol they are using, the JSONRPC 2.0 like, into a real JSONRPC 2, which should be a generic one, so we can rely on the same library on client side and so on. So it gives us a factorized stack at Eclipse.
But then,
and then if we manage to have enough clients, we can use influence and
we wouldn't have the same problem that they have, that all the existing debuggers would not work in Che and Eclipse. I mean, that's the reason why we want to have it, because we want to reduce those 29 debugger adapters.
So-
I think it's a good solution to say, well, we have a legacy mode and a clean mode, and if you develop a new debug adapter, use a clean mode.
Yeah. Yep.
Maybe we have to make pull requests to all 29 debug.
Yeah, going with that, it could also be likely that we will have to maintain those two modes forever.
Yeah, that's the danger. Stop.
Okay.
Alexa says stop.